In the 19th century, George Frederick Kunz described the special lure of gems. The love of precious stones is deeply implanted in the human heart. All the fair colors of flowers and even the glory of the sunset clouds only last for a short time. But precious stones are the same today as they were thousands of years ago, and will be for thousands of years to come. Almost all solid, non-living matter in the universe is mineral, including most rocks and stones. Gems are especially prized minerals. Not all minerals are gems, but most minerals are crystals. Crystals are one of nature's most fundamental forms of matter. Minerals crystallize at rates measured in days or millions of years. Crystals may form under gentle conditions, in shallow pools, or at great pressure, miles beneath the Earth's crust. Crystal faces reflect their internal order. Gems, the flowers of the mineral kingdom, are very rare crystals, formed under special conditions favoring spectacular growth. Heat, pressure, and the distillation of pure elements and compounds combine in many different ways. Each process is an expression of nature's fundamental drive to bring matter and energy into perfect balance and perfect stability. Earth processes work on a monumental scale to form minerals and gems, the non-living masterworks of nature. There are thousands of mineral wonders in the National Museum of Natural History in Washington, D.C. Every year, more than 5 million people come to see the most comprehensive mineral collection in existence. The Gem and Mineral Hall is one of the most popular exhibits of all the Smithsonian museums, and no wonder. On display here are some of the most famous jewels in the world, gifts by many generous donors. The Marie Antoinette earrings. Some believe they were a gift from the king, her favorites, but left behind in a drawer when she tried to escape France during the Revolution. The Napoleon necklace, 172 diamonds, 275 carats, a gift from the Emperor Napoleon I to his second wife, Marie-Louise, celebrating the birth of their son. The diadem was also a gift for their marriage. The Inquisition necklace. The central emerald is one of the finest known. Scientific tests have verified that it came from Colombia at the time of the Spanish conquest. The color, beauty, and clarity of all the jewels in the collection is unsurpassed.
Well, we can keep dreaming. I can go on and look at all the other things. It's fun. But I just love coming here.
The huge Pearson diamond from Brazil, nearly 17 carats. Fancy diamonds of rare color and cut are also a specialty. The early history of the 31-carat Eugenie blue diamond will probably remain a mystery forever. Yellow diamonds are relatively common, but the shepherd is exceptional, nearly 18 carats. One of the most valuable diamonds in the collection is the pink diamond, a favorite of connoisseurs. Red diamonds are the rarest of all. The undisputed masterpiece of the collection is the unparalleled Hope Diamond.
You know, to be honest, I didn't realize the Hope Diamond was blue.
The Hope's fame derives from its intense blue color, its extraordinary 45.5 carat weight, and the legend of a curse. The diamond from which the Hope was cut weighed 112 carats, 66 carats larger than the Hope today. As with many large gems from India, the prevailing legend says that long ago the diamond was stolen from the eye of an Indian icon. This act of transgression cursed all owners forevermore. History says that the stone was bought in India, probably at the Kollur mine, famous for its colored diamonds. The buyer, Jean-Baptiste Tavernier, exotic adventurer and gem trader to the French court. He sold the incredible blue diamond to the Sun King, Louis XIV, along with 24 large stones and over 1,000 other diamonds. To enhance its brilliance, the blue diamond was recut to 67 1/8 carats. Later, Louis XV mounted it in the Golden Fleece, a medallion only kings could wear. Known as the French blue, it became a supreme symbol of the monarchy. As part of the crown jewels, the French blue was handed down from Louis XIV to Louis XV to Louis XVI. Louis XVI was overthrown during the French Revolution, and one night in 1792, the crown jewels and the French blue vanished in the heist of the century. No one knew or would say what had happened to the French blue. Deep mystery surrounds the whereabouts of the blue diamond for the next 20 years. Smithsonian researchers now believe the fabulous French blue was recut to 45.5 carats in an attempt to disguise it. And that later, England's George IV bought it to make peace with his last mistress. The diamond was likely sold privately when the king died, deep in debt. The Hope diamond acquired its name from 3 generations of the Hope family who owned it next. A bankrupt heir finally sold it. The diamond changed hands again and again. In 1912, Pierre Cartier sold it to the beautiful and superstitious Evelyn Walsh McLean. Her life, a tale of glitter and tragedy. Stories of the Hope curse flourished. When Mrs. McLean died in Washington, D.C., her friend and executor, the United States Attorney General, spent most of the night riding around in a taxicab with the Hope in a box, waiting for the bank to open. The McLean estate jewelry was bought by Harry Winston. The most famous gem dealer in the world now owned the Hope diamond. In 1958, Mrs. Harry Winston presented the legendary diamond to the permanent collection of the Smithsonian on her husband's behalf. A tale of 3 centuries had come to an end.
Gorgeous. That is gorgeous.
But the power of the blue diamond endures. Gem cutter Sean Sweeney first felt the special lure of gems when he was a young boy.
Probably the most exciting thing that ever happened to me was, I think, 14 years old, 12 years old, something like that. I was collecting at an old abandoned mine in Virginia. And within a couple of minutes, I dug up a very, very, very large specialite garnet. It weighed over 3 pounds. It was almost 7,000 carats in size. one of the largest in the world.
Because the gem and mineral collection is so large, 98% of it lies behind locked doors.
Sean Sweetie to see John White.
And password?
Beam me up.
Only a privileged few gain access to the hidden treasures.
I've cut a couple of stones for the museum, for the Smithsonian, something that they've collected or is in the collection, and that would be more like your exotic stone.
Sean is here to see John Sampson White, curator of the Smithsonian Mineral and Gem Collection, and an old friend.
I've known John since I was a kid. John judged a mineral case that I put in a local county show when I was 12 or something like that. And I've known him since then and respected him because he liked what I did and gave me a very high score on my case.
These are the gems the public never sees. Each is special in its own way, a prized specimen in a gem collection numbering 9,000.
Oh, there you go. That goes with your pink shirt. Yeah.
Drawer after drawer holds treasure. Unusual gems. Geologic rarities.
Another variety of things.
Unique cuts. Exotic oddities.
These are fun to show people because so many believe that the garnets are always red and that's the only color it comes in. Whereas here we get a wonderful range of colors from the African localities in Kenya and Tanzania. Aren't they beautiful? So you said something about cerussite, carbonate, very colorful.
Isn't that stuff spectacular?
It's gorgeous.
It has such a high refractive index that, you know, almost before the light gets back out of the stone, it breaks into color. You know,
With the double refraction, it
Yeah.
takes all those colors and multiplies them.
makes diamonds look almost dull.
Cerussite. Brilliant, but too soft for jewelry. Kunzite. Named for the 19th century crystal connoisseur.
That's not exactly small.
Feldspar. The sunstone of many colors. Tourmaline. Many of the finest tourmaline gems come from America. Topaz in a natural state may be blue, orange, or yellow.
It hasn't been heat treated. It's the only one like it that I've ever seen this color. It's orangey color.
Morganite is often treated with heat to make it pink, but rarely seen in its natural orange color. This cut tanzanite is the second largest in the world. Discovered about 20 years ago, it is a rare gem-quality variety of an otherwise common brown mineral called zoisite. The single source of tanzanite, one mine, is now depleted.
Let me
The real value of it is in that blue color, so that's what they highlight.
Gorgeous gems, rare, unique, but not necessarily flawless. Up close, Sean can see inclusions, minute impurities or flaws in the crystal. Under a microscope, needles of rutile, tiny host crystals or bubbles of gas, pinpoint a gem's place of origin or prove a stone's identity. Inclusions are the intimate birthmarks of gems. Fakes, or synthetics, usually won't have flaws. Such imperfections prove a gem's natural origin. Even diamonds are made precious by impurities. Trace elements create the colors in fancy diamonds. The hope is blue from boron. Nitrogen makes diamonds yellow. No one knows what makes diamonds pink or red. Red diamonds are so rare that no scientific tests have yet been taken to explain their color. Only 5 are known to exist in the world, The only one on public display is just over 5 carats. It arrived at the Smithsonian in a plain box.
Just as it is, right through the mail, without any fanfare, no armed guards, and a little receipt inside that says 1 large red diamond. Is that understatement or what?
That was all the security behind bringing this in?
That was it, yeah. Well, anonymity is the best security. Generally, that's the way they tend to operate.
Security in the gem business, the trick of the trade, and the obsession of one man, the king of diamonds. Harry Winston, at one time or another, owned 1/3 of all the world's most famous diamonds. Lloyd's of London insured this man on one condition, that his face never be photographed. Winston grew up the precocious son of a modest jewelry store owner in Los Angeles. At 12, young Winston spotted his first gem deal in a pawn shop, a 2-carat emerald on sale, by mistake, for 25 cents. Winston took this lesson to heart. By the time he opened his jewelry store on 5th Avenue, he was one of the most knowledgeable gem dealers in the world. But Harry Winston always worked behind the scenes. He can't be seen anywhere in this film of his store. Winston's designers recut and reset famous and forgotten gems alike. The King of Diamonds had discovered a new kind of mining. He bought up entire jewelry estates and transformed them into brilliant new masterpieces. Specialized gem cutting is an art as rare as the gem itself.
Could you do that?
If I had the equipment, I could, yeah. But I couldn't, I don't have anything heavy enough to do something like this at home.
But is the mathematics all worked out in advance? The sizes,
Yeah.
facets, and the positions and settings and all that?
You could treat it, yeah, just like you would, you could plot it out before, yeah. You could count around and do it, it's just like doing a gemstone. You lay in a girdle almost. And you break the 360 degrees or whatever up into so many planes.
Do you develop each face sort of step by step, or do you grind one face, that's the size,
No.
and then you go on to the next one, and you assume it's going to, because of your computations, it's all going to meet at exactly the right place? Have you seen the rosebud cut? This is rather spectacular. He's got curved facets in the pavilion that are really incredible. I don't know how he does it. The man is one-armed. He isn't going to patent the technique because he doesn't want other people to know how he does it. He'll probably take the secret to his grave. Isn't that wonderful?
It's
I
interesting.
love the way the
It's
light
real smooth.
dances around as you turn it.
It's almost like a cross between carving and faceting. It's very smooth.
Mhm.
Most people, like me, people who professional cut for a living, pretty much have most of the designs in our heads. I don't refer to a diagram. I have an idea of what I'm going to do on the stone, and it's all done there. I cut the bottom of the stone, pavilion first, which I do because to me the angles of the pavilion are the most important in the finished product of the stone. The stone is going to reflect back by how you did the pavilion, the bottom of the stone. If you've cut the bottom of the stone poorly, the finished stone is going to look poor. So it's most important to me to do the bottom of the stone first. The most difficult thing is the transferring process, going from one side to the other, because there's a lot of possibility of error in that stage, things shifting out of true or sync or whatever. And unless you really know a lot about cutting or something like that, you can have problems when you go to start cutting the crown. If it didn't transfer properly, everything might be out of whack. That's the hardest thing to teach somebody how to do. I never mess up. You can judge beforehand. if you're going to have problems with a stone. Very rarely will something come out and surprise you. It's happened. Usually it's with an exotic stone, something unusual, that you can't really judge what's going to happen to it. You can affect the color a little bit with cutting. You can, make a dark stone lighter. You can sometimes intensify, not truly, but optically, you can intensify the color, make a stone look darker by cutting, by angles and design and stuff like that.
An artist's touch, the fire of imagination sparked by knowledge of a deep logic, the natural laws of crystal structure. Diamonds as they form in molten stone. What force in nature inspires this magic? Garnets sprouting on quartz. Ruby, the same as sapphire, only red. A tumble of emeralds. The rainbow shimmer of opal. Rare gem and common mineral, all are crystals. There is a precise order that lies beneath the variety of surfaces.
Today, crystallographers are most interested in studying the actual arrangement of the atoms within crystals.
Dan Appelman, chairman of the Department of Mineral Sciences at the Smithsonian, has studied crystal structure for more than 2 decades.
The main thing to know about a crystal is that a crystal is a very regular arrangement of matter. It's very highly ordered. It's disciplined. These beautiful, regular cubic crystals of pyrite have their regular form because the atoms of iron and sulfur of which they are formed are arranged in a very regular way inside of them. A basic motif of iron and sulfur atoms is repeated over and over again in 3 dimensions, stacked like the bricks in a brick wall, so that the stacks in 3 dimensions of these building blocks of bricks give us the 3-dimensional cubic arrangement of the crystal itself.
Crystals are studies in mathematical form. In all, there are 230 possible crystal symmetries. But this internal order is not always evident.
A lot of times crystals grow in a very irregular fashion. Maybe a lot of crystals start to grow all at once and they're all crowded together so that you can't really see any of them developing those beautiful faces. But on the other hand, if they have the right conditions to grow under and nothing is interfering with them, then they will usually grow with faces that reflect the regular arrangement of atoms inside of them.
Some of the conditions that influence crystal growth are heat, pressure, and chemical concentration. For any given set of conditions, the atoms in a crystal will always try to arrange themselves into the most stable structure. Quartz, one of the most abundant minerals, comes in many varieties, and the Smithsonian collection is the largest in the world. There are thousands of specimens. Even though it is a very common mineral, quartz has unusual properties that make it one of the most studied materials by specialists such as Jeff Post, Paul Poat, and Russell Feather.
Oh, that's very good. It's amazing. A little bit of an impurity can make such a difference in color, isn't it?
Yep.
So, well, and then we got, oh, that's a pretty piece of amethyst, too.
Yeah, we got that last year.
Well, this one's quite interesting one. This scepter, doubly terminated, from Brazil.
These are called Carrara diamonds. Very similar to Herkimer diamonds.
But they aren't diamonds, of
No.
course.
No, of course not. little quartz, a little cassiterite right here,
Oh,
and a little
Kenor,
ferberite. Right on.
Jeff Post and other scientists are
Like very
able to
typical,
study the
quartz.
atomic transformation of crystal structure. They can do this by observing the changes in quartz when surrounding conditions are manipulated. Time-lapse microphotography shows the growth of crystals. Crystal growth is a dynamic process, whether it takes days or years. Rocks and stones are composed of many kinds of mineral crystals bonded together. During formation, crystals compete to form a chemical jigsaw, a multi-mineral mosaic. Interpreting the crystal tapestry is the work of many scientists, crystallographers, geologists, and chemists. Over 3,000 minerals are known, and each year nearly 60 new species are discovered in rocks, stones, or meteorites, a specialty of the Smithsonian since the early 1800s. To help discover the mineral makeup of rocks or meteorites, a thin section is cut. Images that look like abstract art hint at space events that have occurred since the creation of the solar system. These are windows into the distant past.
My job is taking care of the meteorite collection at the Smithsonian. It's one of the largest collections in the world, probably the largest collection in the world, so most of the material that people use for research comes from the Smithsonian collection. And I spend probably most of my time selecting samples for people to fill the requests that we get from all over the world, and I pack them up and send them to people for their work. Mostly we find meteorites just by luck. Somebody will notice an unusual rock in a field or anywhere, really. The most unusual way of all is for somebody to see one fall out of the sky, but that hardly ever happens. If it came out of the sky, one thing that people report is that they'll hear booming sounds because a meteorite in space is going faster than the speed of sound. So when it comes through the atmosphere, it's slowing down and breaking the sound barrier, so people will hear detonations. And another thing that people see is the fireball, the bright burning of the meteorite in the sky. The best place in the world to go hunting meteorites is Antarctica because of the configuration of the continent and of the thick ice and of the movement of the ice. There are certain areas in Antarctica that the ice has moved the meteorites into certain areas where they accumulate. Because there's hardly anywhere else in the world you can go out and find a meteorite. So after working here for several years, to be able to go and see a meteorite lying on the ice that had never been found before, to me was exciting and lots of fun. If you like camping, then it's a 2-month-long extreme camping trip in extreme conditions, but Antarctica's beautiful. And I think the best part about it was to actually be able to find meteorites. You travel on snowmobile down there, and you travel to these areas of exposed ice, and when you see a dark speck lying on the ice, you go over and see if it's a meteorite. And we'd wave and wave till the other people could see that you had found a meteorite, and everybody would come over and see what kind of meteorite they had found. From the field season when I went to Antarctica, about 300 fragments of meteorites were returned. And out of those 300 meteorites, there's only one iron meteorite that was found. This is the iron meteorite that was found. It was the only meteorite we found that day. It was the day after Christmas. And it was lying sort of upside down on the ice like this. And you don't touch meteorites. They're collected in very strict collecting procedures. But just by looking closely at it, we could see the shiny metal and we knew it was an iron meteorite. It's also a beautifully aerodynamically oriented specimen. And of course, it's already been cut here for the preliminary classification and identification. I think that what it made me appreciate more is that in Antarctica, you can go and in one season pick up a couple hundred different pieces of meteorites, which means that you're collecting a couple hundred samples from outer space.
The Smithsonian Department of Mineral Sciences is the only facility in the world equipped to cut large iron meteorites.
This meteorite came from the asteroid belt between Mars and Jupiter.
Tim Rose, Smithsonian meteorite specialist, cuts a section from the core of the meteorite.
In the process of cutting, preparing this section, we have to use as many measures as possible to prevent any kind of contamination, any type of heating that could alter or deform the metal. The only way known to do this is with a wire saw of this type. It's this meteorite. It's about 3,000 pounds. It's basically solid iron. It's about 5% nickel. It'll take in excess of about 100 hours of operating time to cut through and produce about a 1-inch slice.
Meteorites are by far the oldest objects in the museum. Nothing else comes anywhere near close. I mean, 4.6 billion years is a good long time back.
Because most of space is an extremely cold, near vacuum, meteorites are like preserved time capsules. Some have led mysterious other lives in space since the time the planets were formed.
This meteorite came in and it wasn't tumbling. It stayed in one position. That's why it's shaped like a boomerang in cross-section.
Meteorites are classified by a crystal pattern that is revealed by etching with a weak acid. This pattern was once thought to be uniform for any given meteorite. But the Old Woman, a huge meteorite named for the mountains in Southern California where it was found, upset this belief. Its etched surface revealed a range of patterns. It was the first time this was ever seen. What does it mean? The Old Woman remains to be deciphered. Each meteorite is unique. What will be discovered next? Theoretical work must draw on a large body of research. Work done in this lab by Smithsonian chemists Joe Nealon and Eugene Jarosewicz includes analysis of materials ranging from meteorites to new mystery minerals, lunar samples to antique coins. It was here that Eugene Jarosewicz developed a meteorite standard by analyzing powdered samples of the Allende meteorite.
That looks like nickel. That's what it is.
Scientists from around the world investigating the makeup of meteorites draw from these results and rely on the Smithsonian for the samples they need for their own research.
This is so-called classical chemical analysis of silicates. We do this because we have a special samples, and that is samples like meteorites, minerals, even though they can be analyzed with modern instrumental methods, Some of them require special preparation or special analysis for which the instrumental methods are not available. And since our collection are very rich in meteorites, special rocks, and minerals, we have this capability of analyzing this variety of sample.
The techniques of chemical analysis originated with the secret experiments of the alchemists. Chemists and alchemists have both looked by instinct to the process of change and transformation to decipher the mysteries of nature. Alchemists sought to turn base elements into gold, the symbol of perfection. They believed that the unseen forces of spirit could radically affect the outer material world. Alchemy, the change of one substance into another substance, one energy state into another. Then magic, today science. In gold, in crystals, and especially in gems, many people have seen the distilled essence of universal forces, the perfect intersection of spirit and matter. Gems and crystals were believed to have many powers, the power to heal or prevent disease. Gems have long been used as religious symbols, the conduit between worlds spiritual and profane, and as emblems of the influence of heavenly bodies on the actions of men and women. Birthstones are a custom derived from associating gems with astrological signs. Since ancient times, seers have believed that crystals focus the energy forces of the universe, allowing them to foretell the future.
It's a world going amok.
This is the largest crystal ball in the world, and it's at the Smithsonian. The original crystal was discovered in Burma, ground in China, and polished in Japan.
Can you feel the magic coming through to your hand? It's this magic that enables you to foretell the future. If you look into the future, you can see so many things.
Rainbow! Wait.
Minerals, opening new windows of discovery, creating new ways of seeing, and new measures of value. Of all the crystals known through time, diamonds still continue to captivate the imagination and serve as one of the ultimate standards of value. The incomparable diamond, previously known as the Zale diamond, was recently on special exhibit at the Smithsonian.
One is that it's the largest fancy colored, that means not colorless, diamond in the world. It is the second largest cut diamond known, and the crystal from which it was cut was the third largest diamond crystal ever recovered from the earth.
Did I understand you correctly to say that the diamond was for sale?
It is our understanding that the diamond is for sale. Yeah.
What would be a fair market price?
I have no idea.
I just bid it right then.
What is its value? What makes precious stones precious? In the scale of geologic history, the human exploitation of gems and minerals is short-lived. In the quest for perfect beauty, nature's treasures are unearthed by brutal means. But when mineral sources that may have taken millions of years to form are mined out, they are gone forever. Value can be defined in many ways. Gem dealers and gem collectors create special values.
$11.5 million against you. 12 million. 12 million and a half. Last chance for anyone in the room at $12.5 million. We shall then withdraw it from the sale.
There is value in beauty. There is value in rarity. Value can be enhanced by history or by legend. There is value in minerals for scientific inquiry. The work of the Smithsonian is vital. The collection of specimens and the conditions of their recovery are a public treasure for future generations, long after any other sources may have vanished, and long after new values have been discovered.
Founded in 1846, the Smithsonian Institution is now the world's largest museum and research complex. In Washington, D.C., the Smithsonian operates 13 museums, exploring an incredibly diverse range of knowledge. The wonders of planet Earth and the life it supports. The history of the United States. Magnificent works of art from this country and from around the world. And the story of human flight. Also in Washington is the National Zoo, a center for wildlife research. Elsewhere, the institution operates the Smithsonian Tropical Research Institute, the Smithsonian Astrophysical Observatory, and the Cooper Hewitt Museum of Design in New York. You can become an associate member of the Smithsonian and receive a wide range of special benefits, including a subscription to Smithsonian Magazine. For information, write to Smithsonian Institution, Washington, D.C., 20560. The Smithsonian Institution, America's National Museum.